of your little handout thing I gave you. When we have a fluid, or to figure out what our drop factor is, or our drop rate is, drops per minute, because that's the first one we're going to do. You have the formula that you're going to use, and I erased it right there, but you're going to use the number of milliliters to infuse. So if you look at, I'm halfway down on the second page, where it says rule, solving IV calculations with macro and micro. Remember, micro is how many drops per minute? 60. How many is macro? Depends on the number, either 10 or 15. Let me tell you something. Are y'all listening? It is much easier to multiply 10 as opposed to 15. So we would love to see 10 as opposed to 15. But it's wherever you go. Rowan's 15, Northeast is 10, right? Northeast is 15 and 10. Oh, I had them backwards. Sorry. So, Rowan 10, Northeast 15. All right, what we need to do is we need to figure out how much fluid needs to infuse and how many minutes we need to infuse it. So if you look, if you see that TF on here, that is the drop factor. They use two-factor. I say drop factor. Two-factor, drop factor, same term. Same term. Okay? So, if you see the order is to infuse 120 mLs of IV fluid over 60 minutes with a tubing factor or drop factor of 10. So, I need, the first thing I need to put up here is how much fluid has to infuse. 120, right. Times, which is what? My drop factor over 60 minutes. So it's the amount of fluid. And this is easier for me to say it this way because it makes more sense to me. If I've got 120 cc's that has to be given in 60 minutes, I'm going to then multiply that by 10, which is my drop factor. So I sort of separate this and maybe put it over. It's just easier for me. That's much easier to say because I'm putting the numbers that I have together. 120 cc's over 60 minutes, and my drop factor is 10. Is this running pump or gravity? Gravity. So you already know, because of its drops per minute, it's gravity. Right? So you're not going to worry about a pump right now, are you? All right, so I've marked that out. What's that? 2 times 10 is 20. So it's 20 drops per minute. Is that hard? Very simple, isn't it? Are you given the information?
Yeah.
You're given the information. All right. You want to do another one?
Yes.
All right. So let's go to the page with examples on it. Or no, I think there's one back here. No, I don't want to do time yet. Okay, here we go. We have got, or no, I don't like that one. It says pump, 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 pump. I don't want pump.
The macro drip.
All right, let's do this one. If I've got 1,000 cc's, oh no, I hadn't told you that yet. Wait a minute. I haven't got to that one yet. I'm trying to find an example. All right, we'll make one up. If we've got 100 cc bag, and I got to run it in 30 minutes, and I'm going to use 10. 100 cc bag, run it in 30 minutes, 10 drop factor. Come on, 3 into 10.
3.3.
What is it? 33?
3.33.
It's
33.
times 10.
Times 10 would be 33.
Okay, so it's 33. That's exactly what I wanted to happen. Can you give a 0.3 of a drop? No. You cannot. You have to round into a solid number. It has to be. So I'm going to be doing 33 drops per minute. That is probably one of the most common ones you're going to see. The other one, let's do. Remember, okay, y'all do this one. I'll write it up here, but y'all do this one. What did I say a while ago about piggybacks? Because generally these are piggybacks. I said 100 cc usually runs in an hour. So do 100 cc's over 60 minutes and do your drop factor of 10. All right, come on, y'all. This is math. You got a 100 cc bag running over 60 minutes. That is one of the most common ones you're going to see. It come out to be 16.66666. So what's that going to be? 17. 17 drops. That is one of the most common ones because when we have an antibiotic of 100 cc's, it's generally going to run in 60 minutes. All right, if we've got a 50 cc bag, 50 cc bag, how long does that usually run? 30 minutes. Let's do 10. 50 cc's run in 30 minutes with a 10 drop factor.
That's just happened.
Ha 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 ha. Same thing, isn't it? All right, now let's see if we can do this. What if we have a 100 cc bag to run in 60 minutes and we got a 15? 100 cc's, running in 1 hour. So 100 over 60 times 15. No, we don't like that 15, do we? That's what you're used to. That's what you're used to 15.
Per minute.
Huh? Oh, yeah. All right, so we had a 100 cc bag run in 60 minutes, and it was over 15. Over 60 times 15.
Got 25.
Oh, you're around at 25?
What'd you get? 24 point what?
100.6.
Okay. You gotta carry it all the way out, or did it come out even?
Mine come out even.
Come out even? So 25. All right. So if this was an IV piggyback, what would I have done, guys? I got 25, right? What would I have done? 25 to make sure that I counted enough drops for one, because that is drops per minute. So if I have 25 drops a minute, am I going to stand there the whole minute? No, I am not. I'm going to divide that by 4. So what did you get? 6 point. So that would be 6. If it's 6.25, you would do 6 in 15 seconds. Y'all with me?
Yeah.
Okay, if you had your end result was 25 per minute, drops per minute, you're not going to sit there for a whole minute.
Right.
You're going to do it for 15 seconds. So you divide that by 4 because there's 4 15 seconds in a minute. So it's 4 divided into 25, which will be 6.2. I can't give a 0.2 of a drop, so I have to round, and the nearest one is 6. So I would be calculating, that is what you're going to do in checkoffs. You will do the calculations, you will see your drops, you will get the final number. So when you hand in your paper, you're not telling me how much you're going to do in 15 seconds. You're going to tell me how much you would do in an hour. So it's going to say to you, there is 100 cc's. You're going to run it in 60 minutes. Your drop factor is 15. You have done your calculations. It says 25 drops per minute. Woohoo! We got it right. When you come and do your checkoffs, you're going to have this up. You're going to back prime your piggyback, and you're going to fix this at 6 drops per minute. For 15 seconds. And that's all you're doing for IV checkoffs. Because you've already done your 100% on your medication test. Okay? Now, let me just tell you, looking at board questions, they're going to give you all the information that you need. I'm going to give you all the information. But they also like to throw in the medication with the dosage in there. So they may say Anceft, 1 gram, mixed in 50 cc's to be run over 30 minutes and using the 15 drop. Are you going to worry about that grams? Because that is not the information you need. Isn't that a little bit different from what you're usually looking at? You're usually looking at the dosage. But when it comes to IV fluids and rates with that, you are looking at the amount of fluid that has to be infused over X amount of time. Okay? So don't even worry with the calculations about the drug. That is done in a separate part of the calculations. Okay?
Is the medication just going to be all IV stuff?
No.
It's going to be stuff from last time?
No, it's going to be stuff from last time. POs, sub-Qs, and IMs.
And IV, all of it.
Yes, IV. All right. So we've got the drops per minute. Right? Got drops per minute. With me? Amount of fluid divided over how long we're going to run it times the drop factor. Gravity, drops per minute. All right, if you look at a pump, the order says 120 milliliters to be run over 60 minutes. How do you measure a pump? Milliliters per hour. Is there any calculation that needs to be done right there? Why not? Tells you exactly what you have to do. So what do I have to do? If the doctor wrote 120 milliliters of fluid over 60 minutes, I just go right into the pump, and what do I put in there? 120, because it's 120 for 1 hour, and the pump measures milliliters per hour. No calculations. Is that what the doctor's going to order?
No.
Yeah. He's going to say he wants an IV fluid bag of at 120 cc's an hour. There is no calculation that have to be done whatsoever with that. All I do is plug in the thing. That's all I have to do. If he gives you that information. Okay? All right. So now, let's do another one. All right. There are also times that the physician might write an order that says he wants 1,000 milliliters of D5W to run from 8 a.m. to 8 p.m. How many hours is that? That is 12 hours. So I know that 1,000 cc's has got to infuse in 8 hours. So I've got to figure out, 12 hours, excuse me. So I've got to figure out how many, what, per what? Milliliters per hour, because I'm running it on a pump. So if I know I have 1,000 mLs that has to be run over 12 hours, all I have to do is say 1,000 divided by 12 equals 83.3. 83.3 what? Milliliters per hour. Can I run this?
No.
Cannot. Can I put in a pump 83.3? No, I cannot. What am I putting in the pump? 83. Okay? Now, when you do your calculations on your test, and I'm telling every one of you right now with 3 instructors as my witness, when you do your calculations, if you do not have your measurement there, milliliters per hour, drops per minute, it is wrong. Period.
They're naked.
I don't care if you have 83 there and you did your math right, it is wrong. Because you are not telling me how you are running this. It has to be, I have to know. You could be saying 83 drops per minute. Is that right? No, it's not. So I've got to get you to understand, and why did the first thing I said to you this morning? Milliliters per hour. Gravity, drops per minute. Why did I say that? I've got to know that you know the measurement. Okay? All right. Next one. I've got to make it, so this one was pump. Let's do one with gravity. So once I hear the word gravity, I know it's per minute. Y'all get sick and tired of me saying that? You gonna remember it? Yeah. Okay. All right. I have 500 cc's to run in from 12 noon to 4 o'clock. And I am using a micro drop, which is 60. Okay, so what is the first thing I need to figure out? How many hours, right? How many hours am I going to run this? 4 hours. But if I know that it's gravity, I got to have it in what? Minutes. So I've got to convert 4 hours. 4 times 60 is going to be how many minutes? Do you understand why I converted this? What's my end result?
Drops per minute.
Drops per minute. This order was hours. I have to convert that to 240. So I've got 500, right? And what is my drop factor? 60? So I have 500 cc's. I'm going to run it over 240 minutes. And my drop factor is 60. Or you could do it like this. I just did it this way. 4 divided into 500. 100. You see what I did? Oh. I'm not teaching you math. No, ma'am, you cannot. Did you hear her question? If you have a 60 drop, can you keep it in hours?
No.
No, because how is the measurement?
60.
Whenever you use a drop, it has to be in minutes. So you have to change that to minutes. All right, why are y'all looking like you're not understanding? Talk to me. Okay, first, are you having problems figuring out what you need, where you need to put stuff? What was the first thing you should have done when you looked at that? If you saw it was giving you a drops per minute, what is your thought process?
Hours to minutes.
It's going to be gravity. Going to be gravity, right? Got to be, because if it's gravity, it's going to be run in drops per minute. So if I have 500 cc's and he wants me to run it in hours, 4 hours, I can't do milliliters per hour because my drop is drops per minute. So that has got to click me right then and say, I have got to change this hour to minute. That's how I came up with 240 minutes. So the setting it up is the same. If I've got 500 cc's, I'm going to run it in 240 minutes. And I've got a drop factor of 60. What is my drops per minute? 125. Did everybody get 125? So if you're going to run this at 125 drops per minute, how much are you going to run it in 15 seconds? 125 divided by 4. So that's 31 something.
Yeah.
You think that's going to be a little bit difficult to run 30 some drops in 15 seconds? It's going to be pretty fast, isn't it? That's when we want to pump. But if we had a pump, we'd have to run it in. All right, look at this. I've got 500 cc's that have to be run in 4 hours. What's my milliliter per hour? Milliliters per hour. If it's not gravity, because I'm telling you milliliters per hour. If you've got 500 milliliters and you've got to run it in over 4 hours, how many milliliters per hour? Because what did you do? You divided 4 into 500. Okay? Is that good? All right, let me try this. Let's do this one right here because this one sometimes gets people a little bit confused. And then I'll do the IV push. And then y'all can go in and do the other stuff that you're going to do. Okay, I have got the order. This is the order. I'm going to run 500 cc's to infuse at 75 mLs per hour. So if I've got 500 and I'm going to run this at 75 cc's per hour. What do I need to do? Divide 75 because this is cc's per, well, excuse me, dang it, milliliters per hour, and this is milliliters. 500 milliliters has to run at 75 cc's an hour. mLs, sorry. Keep doing it. Don't look blank. You're going to get a funky number. You're going to get a funky number. It ain't going to come out right. It ain't going to be right. What'd you get?
6.6667.
Okay. So 6.67. How in the world am I going to run something for 6.67 hours? Lord have mercy. What in the heck is 6.67 hours?
67 is an hour.
Is it? 0.67. Is that? I got 6 hours. I'm okay. I know I'm going to run it in 6 hours, but it's going to take me a little bit more. I got to do what?
Change the 67.
I got to change 0.67 to minutes. How do I figure out the number of minutes 0.67 is?
Divide.
I've got to, so really, can I round that? Can I round that?
I wouldn't because it's exactly really a certain number of minutes if you leave it like that. It's 2/3 of an hour.
Well,
It's an even number of minutes if you, that's 2/3 of an hour.
I'm gonna have to change it. Miss Beaver does dimensional analysis. I'm gonna have to change this to 0.7.
Because it's
Okay, so 0.7 of a minute. So I have to multiply this by 60.
then you've got to get an uneven number of minutes, but 0.66660 is an even number of minutes.
42.
It is.
Well, multiply this times 6. Oh, times 60. In other words, all you got to do, whether you round up or you don't round up, is multiply times 60. That point times 60. And it'll tell you how many minutes it is. It's easier to me to do. It's easier for me to multiply by 60 doing the 7. But either way you want to, do it. Just know whatever that number is right here that you got that's a point something, you multiply times 60 to figure out how many minutes is a 0.67. So I know that I'm going to run this in 6 hours, but I don't know what 0.67 of an hour is. Come on, girl. All right, you may restart it?
Please.
Okay. All right, so we're okay with this, correct? We know how to put that there. But my calculation came out to be 6.67.
So it's 6 hours and
6 hours
of an hour.
in 0.67 of an hour. 0.67 of an hour. Because I have to know exactly how long this runs. So in order to find out what a 0.67 of an hour is, you have to multiply that by 60 because there's 60 seconds in a minute in an hour. 60 minutes an hour, right?
Are you trying to not confuse them with, like, when we're doing decimals, we're usually thinking about it out of 100, and you want to make sure to make a point that you're dealing with 60 instead of 100? Is that what it's supposed to be?
I don't know what I'm confused in for.
I think that's confusing, and I agree that we need to talk about this because we're so used to thinking when you're looking at decimals that we're dealing with hundreds. We're not when we're talking about hours and talking about
Hours and minutes.
Got to thinking 60s. Is that what you're saying?
Yes, that's what I'm saying.
I want to make sure I
Can you say that again? Because I'm not obviously getting it across.
You can multiply that 6.67 by 60, and you'll get how many minutes are in that hour. How many minutes are in
Yeah,
60, yeah.
that's what I said.
Yeah, the thing is, if you know that 0.67 is 2/3, then 2/3 of an hour is 4 minutes. That's what I was doing in my head.
See, I can't do that.
And see, right. See, that's why when I was getting confused, because it was just like, I just know it's still, so 2/3.
Okay, will this help? Will this help? All right, if we get this situation where we've got a point something of an hour, any situation, if you look back at the measurements, will you know that an hour is the measurement is an hour, and there's how many, and you're trying to figure out how many minutes is 0.67 of an hour, and there's 60 minutes in an hour. So how long am I going to run this for?
6 hours and 42 minutes.
6 hours and 42 minutes. 42.
if I move it out to 230, now that's 40, but if you got it off to 6-7, it's 40.2, and now 7, it's 42. So you get like a 2
Time frame. I'm not gonna give you anything like this on.
Oh, thank God.
No, I'm not giving you anything like this, but I want you to know in the real setting, there's going to be a time. Do they do this very often? No, they do not. But it happens. So I've got to let you know. You're not going to see this on the test, I promise you. All right?
On my test, some chemo runs over like 45 minutes, or some of the pre-meds might run over 45 minutes or 30 minutes. And so if you want to say, we've got 100 mLs to run over 30 minutes, how are you going to set your pump? So that we can convert it that way. Because people miss that all the time on my test. So maybe if we can cover it right now, they're not going to keep missing it. Because it's not difficult math, it's just that people get all confused when it's a partial hour. And I think that's a good follow-up to what you just did. You're going to run something so many.
All right, what you want me to run?
30 minutes, how are you going to set your pump? So do something at 100 mLs over 30 minutes, how are you going to set your pump? But do the math so that you can see that. Or over 45 minutes, maybe.
You want to do 45?
Yeah.
All right, we're going to do a pump?
And then how to set your pump. Yeah, because people miss that on my test all the time. And, y'all need all the...
So you got 100 cc's and you're going to run it in 45 minutes.
Yes. 100 mLs are over 45 minutes. How do you set the pump?
So divide it out.
Huh?
Divide it out.
Yes,
So divide 45 into 100. Correct? Is that what you want them to do?
But then you got to change it to milliliters per hour then. See, that's what we're saying. 100 mLs over 45 minutes is how many mLs per hour?
I'm lost.
To divide that.
Yeah, it's minutes.
You get up here, Miss Beaver, because I don't know what you want me to do.
No, not if you see, 45 minutes is three quarters of an hour, and so more than 100 mLs an hour.
Yeah, but do you put the hours? See, that's what I was saying. 60 minutes.
All right, can we wait minutes to do IV push? Did y'all bring the ones with the IV push? Do you know what I mean when I'm talking about IV push? And we're going to practice this from 11 to 12 if it doesn't snow. All right? What this means is this going to be a push of fluid, which is generally a small amount of fluid, that's going to be given in the site closest to the patient. So if this is the patient's IV and here is the port, this is the IV that or the medicine that we're going to give the port we're going to use the medicine in. All right, if you get your sheet out, the first one, if you didn't bring it, that's okay. Share with somebody. Huh?
I don't know what it is.
It's this sheet right here.
The cephaloxacin, the first one.
Yeah.
Okay, so we're cool.
All right, if you don't, I can put it up here. All right, this is how you've got to calculate the medication for an IV push. The first order is Cefoxitin 1 gram IV Q12 hours. The drug label is 500 milligrams per ml. What's the first thing that I've got to do? Whereas we didn't look at the drug a while ago, did we? With IV fluid. Don't I have to do calculations? So if I've got 500 milligrams times 1 ml, and I have to give what? 1 gram, which is also, I have to do the conversion. It is 1,000 milligrams. Have y'all seen this formula before?
Yeah.
Dose over have times quantity or volume. You have to do the calculation to get the correct amount of drug. Okay? So I know that I've got to give how much? 2 mLs. So when I draw up the drug out of the vial, in order for me to have 1 gram of the medication that's ordered, I would draw up 2 cc's. Everybody with me? No problem there. Do you think this is the calculation you're going to be using on that test?
Yep.
It better be. With your PO stuff, this is the easiest one. If you've already done dimensional analysis and you got it, don't let me confuse you. I ain't doing dimensional analysis. If you do ratio proportion to get your drug dosage, don't let me confuse you. But this is the one I use, and this is the one I have to stay with because I get confused easy. Okay, so dose over half times volume. So I know to have 1,000 milligrams or 1 gram, I've got 2 cc's. All right? Now, what I have to do is I have to go to my trusty little drug book. And I'm going to look up this drug because it's IV push. I need to know how many minutes I can push this drug. It's going to tell me in the drug book, you need to push this drug over this many minutes. Now with this one, the drug book stated that this can be given from 2 to 5 minutes. Whose call is that? Whose call is it? Yours. It's your call. What are you going to look at to make that call?
Reaction.
What are you going to look at to make that call?
And the drug is?
What are you going to
The
look
doctor's
at
orders.
to make that call?
The doctor's orders.
Excuse me, what did you say? Oh, Lord have mercy. You get a hug for that. You don't say that in half a patient. Lord have mercy. If you've got somebody who's old and frail like me, and I only weigh 85 pounds, and my eye is a very hard stick, wouldn't I want to maybe push it a little bit longer? I mean, for a longer period of time, and maybe do it slow? Or if you have someone that's healthy and fibrous like me and got big old muscles and big old veins, you think I can handle it in 2 minutes? Probably could. So you've got to look at your patient to see how many, I don't care how many minutes, as long as you know that you can give it between 2 and 5 minutes, you make that judgment call. There may be a time that I say, we're going longer with this one. It also depends on the drug. Do I know it burns? Then, yeah, I can make an adjustment with that too. All right, so I have actually made the decision. Actually, I'm going to do them in every one of the minutes. I'm going to do 1 and 2, 3, 4, and 5. And you may want to do this just to see what looks good. And what I mean what looks good, I'll tell you that in a minute. Okay, if I've got 2 milliliters and I need to run it in 2 minutes, okay? The way you figure out how much, because the whole object is to try to figure out how much are you pushing within 15 seconds. You've got to get an amount of fluid that you're going to push every 15 seconds. Okay? So, if I look at going at 2 minutes, how many 15 seconds are in 2 minutes? 8. So there's actually 8 blocks of 15 seconds, right? And I need to give how much? So if I've got 2 mLs to be gone over 8 blocks of 15 seconds, how much medicine am I going to push over 15 seconds? 0.25 mLs over 15 seconds. So what's going to happen is we're going to insert the medication to the patient. We'll have the whole 2 mLs in the syringe, and you look at your watch, and I have to wait till the second hand gets like on the 12 or the 15 or the 6, but whichever one you need. When it starts at that 15 seconds, you're going to push 0.25. You can do it one of 2 ways. You can push it all at one time and then stop and then wait 15 seconds. You can push it after that 15 seconds has passed, then you push the next 0.25. And how many minutes is it going to take you to push the whole 2 cc's? 2 minutes, because that's what we figured it out. Okay? All right, so let's do 3 minutes. Is the volume going to change? Volume's not going to change because I'm still going to put 2 mLs. And how many blocks of 15 seconds do I have in 12? Math's driving y'all crazy? I'm almost done, guys. All right, did you get that? Wasn't it 0.16766? All right, so now if I'm going to run it in 3 minutes, I'm going to run it at 0.17 in 15 seconds. And it's going to take me 3 minutes, right? All right, 4 minutes.
Do you always run surround up there?
Yes. Oh, well, no. I mean, what was the original? 1.1?
0.16.
Yeah. Yeah, you can, and I'll talk about rounding in just a little bit. Well, I'll tell you exactly when you need to round. Okay, it's usually to the nearest 10. Okay, but I'm trying to prove a point right this moment. All right, so now we're going to do it in 4 minutes. So I have the same amount of fluid, right? How many blocks of 15 seconds do I have?
16.
16. So that's going to equal 0.125, and I rounded it to 3. Okay, so 0.13. All right, let's do 5 minutes. If I'm doing this to prove a point, is the fluid going to change?
No.
No. And then there's how many blocks? There's 20. I'm just going to go ahead and give you the amount because I need to go. I need to let y'all break. All right, let me just tell you something. The reason why I wanted to do it in all 5 or 4 different areas is it is very, very difficult to push a 0.1 of a cc for 5 minutes. That is so hard. But for checkoff purposes, when it says to do it for a minute, to figure out in 15 seconds, this is what you do. In the NCLEX world, this is how you figure it out. Okay? It's very, very difficult to do that. But for the testing purposes, I need you to do it this way. State Board of Nursing wants you to do it this way. But let me just tell you what's going to happen in clinical. And I'm just going to show you one. The book tells us that sometimes it says it can be further diluted. And sometimes it says it doesn't have to be further diluted. I dilute every IV push medication I get. That's just me. And I think they do it as well. Because medication is so damaging to the patient, and it makes us tear patients' veins up. So if we dilute the medication, it's less likely of the patient having phlebitis and infiltration. So when I look at these calculations and I think, oh my gracious, I know that I've got 2 mLs of fluid. I'm going to look and see which one is going to be really easy to add some more fluid to. Can I add diluting normal saline to my 2 mLs? Because I want to further dilute the medication. So if I further dilute this, let's say I'm going to add 2 more cc's. So now I'm going to have a total of how many cc's? 4. So I'm going to have 4 mLs of whatever. And I'm going to run it in 2 minutes. So I'll have 8 blocks, right? What does that equal? Don't you think 0.5 mLs is much easier to calculate than 0.25? Are y'all with me, or are you not following me? Are you having a hard time thinking I'm getting ready to make a nursing judgment call? Right? Because and we've talked about this, it is so hard to know without a shadow of a doubt if I pushed 0.127, get a syringe and try to push 0.127 over 3 minutes. Because what you've got to do is the first one's easy. You can push that 0.17, it's a little hard, but you can push that 1.7, but then you got to figure out, okay, what is 0.17 times 2? So what do I need to go to make sure that the patient's getting the right dosage? So then, after you did the second 15 seconds, you got to add 0.17 to, so you got to know where else to go. So it's are you reassured that you're giving the patient the medicine at the right time? I'm not. And it scares me. And I hope it scares you. because sometimes I can give medicines too quick and patients have major reactions to it. That's why I, one, dilute. Another thing is if I dilute it more, I know without a shadow of a doubt, I can see on that syringe and I can push that 0.5 and stop. And I can do my calculations to know where I need to go next very quickly because that 0.5 is marked right on my little syringe. Does that make sense?
Like if you already have it pulled up, how would you?
One of the major things that you got to do is make sure that you've got this of that med. Okay? After that, you can add fluid. But you got to make sure that you have drawn up 2 cc's because that 2 cc's equals the 1 gram that the physician ordered, right? That is the actual dosage of the medication that he ordered. So if I've got the 2 cc's, is the dosage changing? Am I still giving the patient the right medicine? Does it matter if I added 2 more cc's to dilute it? No. I try to add as much fluid so I can get a number. This is what I strive to get. I'll do my calculations till I can figure out how much fluid can I add to have a total of 4 or have a total of whatever to make my calculations easy for me to know when I push that 0.5 that that patient is getting the medication at the right rate. Does that make any sense? Is it okay to add as much fluid as you want? Within reason. I mean, I'm not going to add 50 cc's. Okay? Because that would be a piggyback then. But things that you would consider for your patient would be fluid, right? Are they on fluid restriction? If they are, then maybe I need to lower the amount of dilutant that I add. Like some of the ones I did, like with this one right here, see, I try to get it at 0.5. So with 3 minutes, I added 6. Or I added 4, so I got a total of 6. So if I have 6 mLs to push over 3 minutes, what am I going to push it at? 0.5. Isn't that easy? Mm-hmm. I added to this one, I added 2 more. So I got 4. So I would push 0.25. That's a little bit easier to do than 0.13, right? And then for this one, I added up to 5 mLs, and I got 0.25. So those are the kinds of things that I want you to make that nursing judgment call in the clinical setting. But for testing purposes, you're going to get the funky numbers. Now, if it says on your test that you do from 2 to 5 minutes, you do not have to do 2 to 5 like I just did. You pick one because you're making a nursing judgment call. If you want to say you want to give it in 2 minutes, do it in 2 minutes. If you want to do it in 5 minutes, do it in 5 minutes for your calculations, because all the calculations will be correct if you did it between 2 and 5 minutes. Okay? All right. I know I went over. I apologize. So Miss Beaver and y'all take a quick break. Miss Beaver and Miss Chandler.